Hello. In this video, we'll be going over how to transmit J1939 messages from the Quick tool. So we're going to first open the Quick tool as we've done in our previous videos and find our example here. So in this video, we are assuming that you've already watched the video on setting up virtual signals, because we will need some virtual signals in our project to be able to send out messages from J1939 or J1939 RX signals. So I will set up a couple signals in this video, but how to do that, I'll assume that you've already watched the video on setting up virtual signals and J1939 signals. So to send out a J1939 message, we're going to use this editor here with the little mail looking message. And if we hover over, it says J1939 transmit message editor. So we're going to go ahead and open that. So on the left here, we see our PG list, which is the list of PGNs. And on the right, we see the SPN list, which is a list of SPNs within the PGN. As in previous videos, I'm going to assume you have some familiarity with J1939 already, so I won't go into what a PGN and an SPN is specifically. If you do not know that, I would recommend either watching the video on J1939 basics or just doing some web searches. So first we need to add a PGN. So we're going to hit add, and you can see this automatically adds in our first SPN as well. So if we click here, we have defaults to PG0. So this is the message name. We can just call this PG Custom 1. The next thing we have, and obviously here you can put whatever message you're sending out. You know, it should be as detailed as possible. That way you know when you see it in the list what it is. So just for this example, we're calling it Custom 1. The next one is our transmit rate. So our transmit rate tells the tool how often you want that message sent out onto the CAN bus. So it's defaulted to 100 milliseconds. We can, change that to 500 or 1,000 milliseconds, which is 1 second. There's a checkbox over here that says on request, and if we check that, the transmit rate turns to 0. So within J1939, there is a system where a node or a controller ECU on your bus needs to request a certain message. So let's look at something like engine hours. Engine hours, obviously, you don't need every 100 milliseconds because, maybe you only change that value once every hour. So a lot of times that signal is on request. So this is saying, okay, don't send out this message, this custom 1 message, every 100 milliseconds or every second, but only send it out if it's requested. And you request that by a special J1939 message that's standard for J1939, so a PGN request. In this case, we're not going to put this on request, but we'll just keep it at, every 100 milliseconds, or we'll make it every, why not? All right, so this next setting, the PGN. So this is the PGN number, or the PGN address or hex value in this case. So you see that it's hex because it's 0x. So we're just going to say 0xFF12. Obviously, as you add more PGNs here that you're sending out, and you need to be careful as well that your controller is not receiving the same PGN from different source addresses. I guess it could, because it will identify that it's coming from different source addresses. So it should be okay, but maybe bad practice. And so, without getting too much into J1939 specifics, there's something called a PDU, which is these first two bytes of the PGN specify this PDU format. So the first two bytes are over 240. So FF is, if we go to programmer and hex, FF in decimals 255. So if it's greater than 240, it's called a universal PGN. So it goes out to, it's not destination specific. You're not saying this PGN is sent only to this node or this source address. You're sending it out on the bus, and every node or every ECU on the bus will pay attention to that message. But if it's less than 240, so we can say, if we make this like AA, then you'll see the next 2 bytes specify the destination address of the node you want to send it to. So if you know the node you want to send it to, for instance, the engine controller, you can, and you only need it to go to the engine controller, you can make it destination specific. But if you want more than one node on your CAN network to receive it, you should make it universal. So, FF or really like anything F1 is also, as long as this first byte, I believe, is F, then it'll be greater than 240. Okay, so, we can say FF00 is our PGN. Here we have our message length in bytes. So a standard CAN message is 8 bytes in data length. So we're going to keep it at the default, but if you want a non-standard message, so most likely if you want a non-standard message, you want it to be greater in length. So maybe you want to have 12 bytes. You can check this box and make it larger. To do that, J1939 handles that behind the scenes. What it actually does is sends out a special message saying to the receiving controller, saying, I'm about to send out a large message greater than 8 bytes. And then it sends out multiple 8-byte messages to get up to this 12 bytes. But in our case, we're just going to keep it at 8 bytes standard. All right, the transmit message or transmit channel tells us what channel or what CAN bus we want to transmit it on. So we can select channel 1, both channel 1, channel 2, or just channel 2. So in our case, we'll just keep it at channel 1. And then down here, we get to the SPN information. So, we can, again, give this a name. So SPN custom SIG1, we'll call it. So next, we have our signal. So this is where we need to set up a virtual signal or a J1939 signal. And we can do both really quick. So you'll see in our previous video, we set up signal custom 1 and password. So we can say, okay, let's say we want to send out the value of signal custom 1 as one of our data bytes. So signal custom 1, we can see we made in our virtual signals here, this was 10 bits in size to represent these values. So 0 to 102 with a bit weight of 0.1, So if we go back to our message editor here, you'll see our data size is 10 bits, as it should be. And our start bit, it's saying is 0, which is fine. We can change that in a second. The SPN number, you don't need to change, but I usually, as I add more SPNs, try to make each SPN a unique number. But that shouldn't matter much for your receiving. So you can make it whatever number you want here, as long as you tell the controller that's going to be receiving this message, you give it the correct number of bits and start bit, that controller will be able to decrypt the message or understand the data that's being sent. Okay, so we have these messages set up, and delimited, essentially you can use these delimited characters. If you want more information about delimited messages, you can click help here, and yeah, it has a little section of how delimited messages work. I would say it's not a normal circumstance. Okay, so let's add, so in a normal PGN, we most likely will have more than one SPN. So because we have 8 bytes of data available in a normal PGN, this 10 bits really only takes up a little over 1 byte of data. A byte of data is 8 bits. So, we're taking up essentially 1.25 bytes of data. So we have a lot more space in this PGN to add some more. So let's just add, a couple more SPNs here. So we'll probably, so Signal custom 1, that actually works. So let's go and quickly add in a couple more pieces of data to send out. So to do that, we're going to go into our signal editor, and we'll just add a J1939 signal from a database. To do this, we'll just search engine speed. So this adds this J1939 signal based on a standard J1939 database. We've discussed this in a previous video, so don't think we need to go over this again. In virtual signals, so let's add, virtual, or the signal, we'll just add a signal that, well, we have our password here, so we'll use that, and then we'll add maybe one more. So we'll say signal screen number. So let's assume that we want to, for some reason, send out the screen that the user is currently on within the quick tool. So we have different screens here. So we could, for instance, give each one a number. Like this could be screen 1, 2, 3, and maybe we wanted to send that information out so a controller would know where the user is currently at. Okay, so let's say we wanted to represent 20 screens. So we've sort of done this before. So we could represent 20 screens with 5 bits of data. So 2 to the 5th would be 32. So 5 bits of data will give us, we'll say max 30. How about 0 bit weight? Okay, so that's good. And signal screen number. All right, so now we've added in a couple other signals here. So go back into our message editor, and we're going to call this SPN screen number, and we're going to come to our signal list, and find the virtual signal that we just added, so signal screen number, and you can, as I mentioned before, see that it's virtual by the V on the left and it's orange. Okay, so as I've said before, I try to make them unique SPN. So, we had SPN SIG1 at start bit 0 and SPN 0. So we'll make this SPN 1. And since this one started at start bit 0 and goes 10 bits, so that's going to go to bit 9. Since bit 0 is an actual bit. So our screen number then needs to start at bit 10 because bit 0 through 9 is taken up by this custom signal. So this needs to start at bit 10, and it's going to move 5 bits. So it's going to take up bit 10, 11, 12, 13, and 14. So our next SPN in this PGN needs to start at bit 15. Okay, so let's add the next SPN. So we'll say SPN password. So here we're going to select our password, and I think we said it needs to start at start bit 15, and that's going to take up 14 bits. So that's going to go to bit 28. So our next one needs to start at 29. And we're going to make this SPN 2. So we have 0 here, 1 and 2. And then the last one we'll do is we'll just send back out the engine speed we're receiving from the engine controller. So, in this case, this might not make a lot of sense because we're on the same bus, but this could be good. So if, for instance, you have 2 buses connected. So let's, for a second, assume your channel 1 or your CAN bus 1 is connected to the engine controller. And then you have a second bus that's connected to another controller that's not connected to the engine controller. So maybe in this case, you want to receive your engine speed from the engine controller on channel 1 and send it back out onto the channel 2 bus to your other controller. So the display can act sort of as like an intermediary to send out messages onto different buses. So if your display is kind of your central link in your system, it can pass messages along between 2 nodes that aren't on the same CAN bus, as an example. In this case, though, we're just going to set it up so it's going to send out our engine speed that we're taking in from J1939. So we haven't modified it. You'll see this brings in the J1939 specific information. So in J1939, engine speed is SPN 190. We can keep that, or we can change it to more be in our system, which this would be SPN 3. And if you remember, our password went from start bit 15 to start bit 28. So our next one needs to start at 29. So our engine speed, the start bit in J1939 is 24, but we're going to change that to our system, which is 29. Okay, and I guess I skipped this priority. So the priority of a message determines, so as messages come in J1939, they're buffered because usually the processor CPU doesn't have enough time to process everything exactly as it comes in. So messages are put into a buffer, and this priority designates their priority within that buffer. So if something is a higher priority, it will be handled before something as a lower priority. So priority 6 is low. We can change that to priority 1 if we want this message handled as a very high priority message. If it's low, 6, somewhere in the middle, 3. So, really it depends on your system and what the importance of this PGN is for this priority. But, okay, so we have everything set up here. In a normal system, right now we just set up one PGN, but normally you would have more than one. So, here we can add a second PGN and call this like custom 2, and go through the same things. So here we have our first PGN being sent out and our second, and we can make it a different transmit rate or a different channel, for instance, that we're sending it out on. Obviously we don't want to set up the same PGN number. So the only thing that you really need to make sure of is if this one is PGN FF00, it won't make any sense. And I don't know if it even lets you do it. No, it does. But so you should never have the same PGN number being sent out from the same source address, because on the bus, essentially you'll overwrite the data from your previous message. So your PGN should always be unique. Yeah, so I think that covers it. I'll go over really quick. So if we just were to do this now, it would send out at 100 milliseconds as soon as we started. In the video on scripting, we'll see that you can also trigger a message. So we could, for instance, click on request, and this would never get sent out unless it's requested, but we could trigger it with a script to send out this PGN message whenever we wanted. So maybe, you only wanted a message, for instance, sent out when a button was pressed. So in that case, we could say on request, and then when a button is pressed, we could trigger it with a script. So that's also possible to do. But we'll go over more about that in the scripting video. For this case, I think that's really all we need to do here. So we've set up essentially 2 messages to be sent out. This custom 2 obviously has no information in it, so this may flag an error. If we can see, if we try to save, build, it may give us an error because it's not, just gives us a bunch of warnings. So obviously that one will send, but it's going to send with all zeros because there's no information linked to it. Obviously, as this first one, we haven't put any data into these signals yet, so you need to assign these to something in your project, and we can do that with scripts. So right now, all of these virtual signals in our project will just be their default values here, unless we put data in them with a script. So to see that, you should go to the scripting video. And I think that covers it. We built, we saved, and if we were to put this on the display now, it would attempt to send out whatever data we had in there. Thank you.